Hello guys, I'm making this video to let you know about Solis app features. So for that I'll be using an iPad since I can show you the web app as well as the Android or slash iOS app version. So let's start with the Solis app on the iOS. So basically that why I'm making this video is to let you know about some of the basic features that I was not familiar of. So starting up with this animation that is going around here. So this animation consists of total 6 sections. One, when it's daytime and the solar is getting generated, the PV input will show the arrow towards the inverter and it will scatter all the electricity to all the other directions. And so the very first thing you see here is the smart load thing, and the smart load thing feature is that it will tell you about those application that are consuming electricity, which are you included in the heavy load slash the load on which you don't want to like say if you have electricity getting generated enough, only then these resources will be started, and when electricity is coming from grid, then only then the smart load will work. It will also work when the battery capacities are 80% or above, and make sure that the backup resource will not suffer in the meanwhile, since backup resource is the resource that you always want to be run. For example, the lights in your house and the router of internet and something like that. So the basic necessity things are included in the backup load, and the air conditioning systems and the remaining things will be included in the smart load things. And these are the things that you didn't want to be running when there is no electricity or there is no power from the solar panels. So these are the basic two load, and you can also see a third load, which is grid load. This grid load is actually here that if you want a load that you don't want on the inverter, for example, you don't want something that depend upon the current status of the inverter, you can add it in the grid load. So it will only work if there is electricity coming from the grid. If the inverter will not provide any kind of electricity to the grid load. So these are the basic animation features, and after that there are multiple sections in this app. These sections are divided as below. So this section will tell us about the current generation of the electricity. For example, today the electricity, since these are the winter days and sun is kind of not generating enough light for the solar panel, so you can see here that it maxes out at 6 kilowatt, and total electricity today generated is around 38 kilowatt, which is equivalent to 38 units. And you can see that 34 of those units are sent towards the grid, which we will get a credit, and the 4.6 of them are consumed today. So if you want to see what we imported, exported, or current status of today, then you move to the month tab and select the date. For example, today is 13, and we can see that the PV generated 38, from which 0 is the grid load, since we didn't apply any kind of devices on the grid load. So here it is showing that grid load is 0, and the backup load is 0.7 kilowatt, so which means that basic lighting and something like that consume only around 700 watts of electricity today. And smart load, since we are using internal heating, so this is related to the smart load that I told you earlier, that it is the heavy appliances and only work if both WABDA or solar panel is generating enough electricity. So the smart load consumed today is 6 kilowatt. Imported is the electricity you import from the grid. So imported electricity show up here. Apart from that, since there is no load shedding or any kind of electricity glitches today, so we can see that the discharge of electricity from the battery is 0 kilowatt, and similarly 0 kilowatt is consumed by the battery to get charged. So yeah, these are the basic stats. Other than that, there is another column for yearly consumption. Here you can see that since it's the first of this year, so it will show the same status like we have seen in the previous month tab. But when we move back toward the last year, we start using this inverter around 6th of 2024, 6th month of 2024. So these are the stats from those months, and you can see that in total we have generated 5.5 megawatt of electricity toward the grid, and consumed only 1.4 megawatts from the solar panels. We imported around 216 units from grid and exported, no, I think I have missed it, since I have selected here 12. This means that it will tell us about the electricity generated, imported and consumed per month. So yeah, you can see per month consumption through this method too. Okay, now coming towards the mainstream, the internal device features. So these are the features you have to look from the web app if I recommend you. Since this is limited to the screen of the devices you are using, so I will recommend you to move toward the desktop app. So from now I will switch toward the desktop app. So for the desktop app, yeah, let me sign into my desktop app. So here, when this is the UI of the desktop app. In the desktop app you can see the plant overview, the device overview. You can also see the different type of reports that if there is some grid alarm or something related to that, there are multiple sections for that. This is more detailed version of the app that we have seen previously. Let me zoom in. Yeah. So here first I have to go back to the main screen, home tab. There, then go to the select the inverter I am currently looking at. So this is more or less same to what we have already seen in the desktop on the iOS or /Android app. Now there is this section name as devices. Go to the device, select the inverter, and here you can see a detailed nerd experience for the same graph that we are previously seeing. So it will tell us about information like what kind of inverter we have, how many warranty we have left, what kind of electricity is getting currently generated from the power, solar panels, and similarly what is the battery status, what is the load status, grid status and inverter status. Now these are the graphs we are more interested in. So yeah, let me start with the battery. Here you can see there is a different section for different input and outputs of the inverter. So I am interested more toward the battery. So let me select the battery voltage. This for example, you have lead acid batteries. These batteries are percentages are not reliable to know what is the current status of batteries. So it's always better to have a look at voltages of these batteries. So here you can see, since there is no power fluctuation or any kind of load shedding, the battery will continue to stay on 55 voltage. The inverter will provide some kind of supporting voltage in order to function batteries properly. It will mildly consume some voltage. For example, it will consume a 20 watt of electricity from the grid / solar panel to keep the battery charged. So it will always remain on 55 volt. Since we are consuming total 48 volts of battery, we have in our current setup we have actually 100 amp hour 4 batteries connected in series, which makes total of 48 volt when charged at for 12 volts. But since the max charge voltage are around 13 to 13.5, so the current battery voltage are showing up as 55 volt. And now let me move toward a day where we have actually consumed the battery. Let me find that day in which we actually consume some battery. So yeah, here you have noticed that there is some fluctuations. So these fluctuations are because of the load shedding. You can see the alarm. Most probably this alarm 1015 will represent that there is no grid, and in that case the batteries start discharging as soon as the there is no solar. Since 1841 means that it is around late afternoon, or perhaps when there is actually when there is no solar energy available. This is the that time frame, and in parallel that you see that the alarm represent there is no grid, and this is the only probability that when we are consuming electricity from the batteries. So on the on the exact time when we see there is no grid, the battery voltage declined from 54 to around 47, and this is the actual voltage of our batteries with load. So 47 is the actual battery of load, and we can consume electricity from the batteries for around 40 volts. So you can ratio that out in a way that 47 mean 100% battery charge, and then 40 volts mean that we are going to cut off all the electricity from the batteries, and it consider that as 0 volt. So this is a graph that represent that. Apart from that, we also have some grid information that I would like to show you. So the grid information, there are some things that are interested to some people. For example, what kind of electricity frequency we are getting from the grid. So this shows that we are getting 50 hertz of electricity, and what kind of power factor. So you can add as many things you want in this graph. At max, I think it will set to 4 parameters, but on the desktop app / web app, it will add as much as parameter you want. So yeah, these are the few features that Solis app provide. So just want to let you know that these are the basic features I was familiar of. Yeah, and since I have to look into the catalogs a lot to understand the different type of representation added in this app. So it's better that if there is a YouTube video that will tell us about these detailed informations. So these are the things that you will be most interested in, and they provided these information in the iOS / Android app as well. So yeah, this is a basic introduction of Solis app.